and welcome to this session on half adders. As we discussed earlier, a half adder is a type of adder, an electronic circuit that performs the addition of numbers. The half adder is able to add two single binary digits and provide the output plus a carry value.
Objectives. At the end of this session, you will be able to construct the half adder circuit and verify the truth table, and familiarize the operation of half adder circuit. Before we begin assembling our circuit, let's ensure we have all the necessary tools and materials at hand. You will need the following tools and equipment such as digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, and tweezer 1 number. You will also need the following materials and components such as IC 7400 1 number, IC 7486 1 number, hookup wire as required. It is also important to recap about what a half adder is. The half adder is a digital circuit designed for the binary addition of two single-bit numbers. It takes inputs A and B, both single-digit binary numbers, and produces two outputs. Specifically tailored for single-bit binary numbers A and B, the half adder computes two outputs, S and C, where S is the sum and C is the carry. Let us now look at the operations with half adder circuits. Case 1, where A is 0 and B is 0. According to the binary addition, the sum stays off at 0 and no carry bit is generated since there is no propagation from lower order bits. Hence, S is 0 and C is 0. Case 2, A is 0 and B is 1. This results in sum output becoming 1 without a carry. The single active bit passes directly to the sum. Hence, S is 1 and C is 0. Case 3, A is 1 and B is 0. Here, the sum remains 1 with no carry bit generation. Hence, S is 1 and C is 0. Case 4, A is 1 and B is 1. This case produces output carry becoming 1 for that upper bit propagation, while sum generates 0. Hence, S is 0 and C is 1. This truth table summarizes the various operations of half adder. Let's now look into the procedure of construction and testing of the half adder circuit using ICs. It involves the following steps. They are: Step 1. Inspect the components and set up the breadboard. Step 2. Connect both IC power pins to plus 5 volt and ground. Step 3. Attach switches for different levels to input. Step 4. Connect both outputs of ICs to an LED with a resistor. Step 5. Test the circuit by toggling switches. And Step 6. Observe and record the readings. Let us now look at each step in detail. Once you are ready, collect all the required components and check them to ensure they are in a good working condition. This includes both 7400 and 7486 ICs, breadboard, power supply, toggle switches, resistors, and LED. Check the digital trainer kit and all the required sections on the digital trainer kit to perform this task. Also ensure the conditions of both 7400 and 7486 ICs, breadboard, and control toggle switches, resistors, and LED. Once you have got everything, mount both the ICs firmly on the breadboard. You can use the circuit diagram for reference. Connect the plus 5 volt power supply of the trainer kit to the positive terminal of the breadboard. Next, connect the 14th pin of both the ICs to the plus 5 volt power supply. Then, connect the ground of the trainer kit to the negative terminal of the breadboard. Next, make sure pin number 7 of both the ICs is connected with the ground. Connect the pin 1 of XOR gate to the switch S1 and the pin 2 of XOR gate to the switch S2. Connect the pin 1 of NAND gate to the switch S1 and pin 2 of NAND gate to the switch S2. The output of the XOR gate, pin number 3 of 7486 IC, gives the sum. Connect the output pin 3 of the XOR gate to an LED indicator. This will give you the sum. To get the carry, connect the output of the first NAND gate, pin number 3 of 7400 IC, to the inputs of the second NAND gate, pins 4 and 5 of the 7400 IC. Interconnect the pin 3 and pin 5 of IC 7400. The output of the second NAND gate is taken from pin 6 and is connected to the LED indicator. This gives you carry. Also ensure the switches can toggle between the 5V for a logic high and 0V for a logic low. According to the logic levels, you'll test as shown in the truth table. Before you power up, get your assembled gate circuit checked. With everything checked, switch on the 5V DC supply. Begin the test by operating switches S1 and S2. Observe the status of LEDs for each step of combinations. When the switch S1 is set low and switch S2 is set low, the output of the sum LED should be off and carry LED should be off. When the switch S1 is set low and switch S2 is set high, the output of the sum LED should be turned on and carry LED should be turned off. When the switch S1 is set high and switch S2 is set low, the output of sum LED should be turned on and carry LED should be turned off. When the switch S1 is set high and switch S2 is set high, the output of sum LED should be turned off and carry LED should be turned on.
This brings us to the end of this session. In this session, we have learnt construction of half adder circuit using ICs and verification with its truth table, and familiarization about the operation of a half adder circuit. Thank you for watching. We will see you in the next session.